Hello, this is Miss Prater, your Algebra 2 teacher, and I am going to review Unit 3. So if you had any low quiz grades in Unit 3 or a low grade on your Unit 3 test, this will be a really good video that you could watch before you retake anything from Unit 3. So this is a fairly long PowerPoint, so I'm going to talk fast at any time. If you want to stop and rewind, you can. I have tried to video this. This is my third try, and what I use to video with only lets me do 30 minutes of video and then it shuts it off. So I want to talk a little bit faster than normal. If you need to stop the video and rewind, please do so. One of the first things that we learned in Unit 3 was we learned about polynomials. In this aqua bubble, it tells us the definition of a polynomial. It's an expression which can contain variables and constants and exponents that are combined using addition, subtraction, multiplication. And then there's a big no. There's something that can't happen. We can't divide by a variable. So anytime a variable is on the bottom of the fraction, or if you're dividing by a variable, that makes what you're looking at not a polynomial. So in these four examples, they're all polynomials except for number 2, because we have an x in the denominator. All of these are polynomials. Number 4 is kind of iffy because you do see something in the denominator, but it's a number, so it's okay to divide by a number, but it's just not okay to divide by a variable. When that happens, then your expression is considered not a polynomial. We have a lot of different types of polynomials, so we give them special names. One way we can give them special names is by the number of terms they have. So if a polynomial has one term, it has a special name called a monomial. If it has 2 terms, it has a special name called a binomial. And if it has 3 terms, it has a special name called a trinomial. They're all still polynomials, so they're under the heading of polynomials, but just because we use them a lot, they have special names. If a polynomial has 4 or more terms, then we just call it a polynomial. It doesn't have a special name. We can also give polynomial names by the highest exponent, which is called the degree. So if the highest exponent is a 1, we call it a linear polynomial, and its graph is always going to be a straight line. If the highest exponent is 2, we call it a quadratic, and its graph is going to be a curved shape that looks like the letter U. And if the highest exponent is 3, we call it a cubic, and the graph is going to also be a curve, but it's going to kind of look like a vertical snake. Beyond the exponent of 3, we really don't have any special names, so we just call them polynomials. But if the degree is 1, we call it a linear polynomial. If the highest degree is 2, we call it a quadratic, and if the highest degree is 3, we call it a cubic polynomial. We also use the degree of the polynomial to determine like how many solutions, how many x-intercepts. So one of the things, once we define what a polynomial is we're going to talk about what its degree is. So the degree is tied to the highest exponent of any term in the polynomial. So the first example doesn't have a variable at all, so we call that a constant. And when you have a constant in your polynomial, and that's a monomial that's just a constant, the degree is always 0. And then you always go with the highest exponent. So in x plus 4, the highest exponent is 1, so the degree of the polynomial is 1. In the next example, the highest exponent is 2, so the degree of the polynomial is 2. In the next example, the highest exponent is 3, so the degree of the whole entire polynomial is 3. And in the last one, this is showing you if you have a term where you have more than one variable multiplied together, you actually add those exponents. So this first term has a degree of 5. The second term has a degree of 4, and the last term has a degree of 1. So 5 is the overall highest, and 5 would be the degree of the whole entire polynomial. So that slide's just explaining how to find the degree of a polynomial. In this Unit 3, we learned how to add, subtract, and multiply polynomials, and we also learned how to factor. So if you're adding, you're going to drop the parentheses. You're going to bring everything down just like it is. Don't change any signs. And then you'll combine like terms. We do like to leave our answer with the highest exponent term first, so we would put the negative 3p cubed first, and then 5p squared and 2p squared are going to combine to be 7p squared, and then this minus 3 will just come down. So we call this standard form, where we're writing the highest degree term first, or the highest exponent first, and then we'll decrease from there. If you're subtracting, I always like to say subtraction is the devil and it causes you to make mistakes. So you're going to drop the first set of parentheses when you're subtracting two polynomials, and then you can either subtract each term in the second parentheses, or I like to think of this as distributing a -1. So it's going to give me a -3n cubed minus 4n. So subtracting, you do have to change the sign of everything in the parentheses that you're subtracting. You can either think of that as subtracting each term, or multiplying by -1. The n to the thirds are the highest degree terms, so I'm going to combine those first. That gives me -6n to the third, and the positive 4n and the -4n are going to cancel. In the next example, we go over the rule for multiplying. When we multiply like variables, we do that by adding their exponents. And then if we have more to multiply, we always multiply the coefficients together, and then we multiply the bases by adding their exponents. So here we have a distributing problem where we're going to do 5 times 2. Those are my coefficients. And then x to the third times x squared, we're going to multiply those x's by adding their exponents. Then we're going to multiply our coefficients. 5 times -7 is -35. And then x to the 3 times x to the 1 is x to the 4. We can't combine those because the exponents are different, meaning the terms are not like terms. When we're multiplying a binomial times a binomial, we can use this little word FOIL, which most of you learned in Algebra 1. It stands for first, outside, inside, and last. And we'll multiply the first terms together. That gives me 40x squared. We'll multiply the last terms together. That gives me -20x. Inside gives me positive 48x, and the last terms multiplied to be -24. Our middle terms are going to be like terms, so we always write our highest degree term first. We combine our like terms, and then we write our terms in the degrees that are going down. So 2 understood 1, and then the 24 has a degree of 0. So remember, this only works for a binomial times a binomial. So it's got to be 2 terms times 2 terms. In my last example of multiplying, I just have a binomial times a trinomial. So FOIL is not going to work here. That's only for binomials times binomials. So we're just going to distribute. 4a times 6a squared is going to give me 24a cubed. 4a times -a is going to give me -4a squared. 4a times +2 is going to give me +8a. And I'll switch colors so you can see what I'm distributing next is the 2. So I get +12a squared, -2a, and +4. Then I combine like terms, looking at the highest degree term first. So it's going to be the a cubed. There's only one a cubed term, so I bring it down. I have 2 a squared terms. They're going to combine to be +8a squared. I have 2 a terms. They're going to combine to be +6a, and then the +4. And then that would be your final answer, because none of those terms are like terms. We are going to talk about 4 different ways to factor. I do think factoring is probably the hardest thing in Unit 3. If you're factoring a trinomial, which is 3 terms, you're going to follow the sign rules. There are 2 basic sign rules. The first one says when the last term in your trinomial is positive, the signs are always the same. And they'll be plus plus when your middle sign is plus. They'll be minus minus when your middle sign is minus. And then the second rule says when the last term is negative, the signs will always be different. So again, you're looking at this last term. If it's negative, it's either going to be plus minus, or it could actually be minus plus. We'll look at a couple examples. And then we're going to follow these directions. We're going to check to see if there's a GCF, and there is a GCF of 3 here. We're going to factor out the 3. And then we're left with a trinomial. We're going to look at the last term. It's positive, and that means the signs are the same, and the signs will be whatever the middle sign is. So I know my factors are going to be plus plus. My first 2 terms have to multiply to be 3k squared, so I'm going to use 3k and 1k. And my last terms have to multiply to be 7, so I could use 1 and 7, or I could use 7 and 1. The order is going to matter here. So it's going to be 1 because these inside terms are going to multiply to be 1k, and it's going to be 7 because my outside terms multiply to be 21k. And these 2 terms have to combine to be this middle term. So this is factoring completely here. And then that last step was factoring a trinomial. We also have factoring the differences of squares, and we use a formula. I love everything on this page because we do have formulas. So for example, if I were factoring x squared minus 25, a would be x because that's the square root of the first term, and b would be 5 because the square root of 25 is 5, and then you just follow the formula. So the factors are going to be a plus b times a minus b. If you're not allowed to factor using complex numbers, and we can't factor a squared plus b squared, but I will tell you that if they say complex factors, there is another formula that I did not put here, but I'm going to put it on this review. And the formula is a plus bi times a minus bi. So for example, if I had, we'll just do x squared plus 25, a would still be x because that's the square root of x squared. B would still be 5 because that's the square root of 25. But if it's a plus and they say you can use complex factors, then it's going to be, the factors are going to be x plus 5i times x minus 5i. If they don't say anything about complex factors, then you would say that x squared plus 25 is prime because you can't factor into real numbers. But if they say you can use complex numbers, then you would use the formula a plus bi times a minus bi. The third way to factor is sum and difference of cubes. These are also formulas. I'll do one example. So we'll name it example 3. So if I had, let's do 27x cubed plus 64. This will be the example of the sum of two perfect cubes. So a is going to be the cube root of 27x cubed, which would be 3x, because 3x cubed is 27x. And b is going to be 4, because 4 cubed is going to give me 64. And then I just take my a and my b and I plug it into the formula. So the first part of the formula says a plus b. So that's going to be 3x plus 4. And this is a 4. It looks like a 9, and it's bugging me. So let me fix it real quick. So that's the a plus b, and then we're doing the a squared. I don't have enough room to write it beside that, so I'm going to write it underneath it. So that's a squared, so 3x squared is 9x squared, minus a times b, so that's going to be minus 3x times 4, which is 12x, plus b squared, so that's going to be plus 4 squared, which is 16. You would do the same formula, the same thing, but the formula is a little bit different. For the sum, you have a plus and a minus here, and for the difference of cubes, you have a minus and plus. But other than that, the formulas are the same. The last way to factor is factoring by grouping. So there's 4 different ways to factor. The clue is usually you have 4 terms. You could have more than 4 terms. They're usually an even number of terms. But for Algebra 2, we usually have 4 terms. And then here are our steps. We're going to group the first 2 and the last 2 and factor out the GCF. So the GCF here is 3p squared. That's going to leave me with 4p minus 7. The GCF between the last 2 terms is 7. That's going to leave me with 4p minus 7. And then we factor out the common group, so that's going to be the 4p minus 7. If you don't get a group inside your parentheses that's exactly the same, that means you made a mistake. So when we factor the 4p minus 7 out of the first term, we get 3p squared, and then out of the second term, we get plus 7. And then those are our factors. We use factoring to solve, and so a quick reminder about some vocab. Roots, solutions, zeros, and x-intercepts all mean the same. So if they're asking you to solve or find the roots or find the zeros or find the x-intercepts, you follow these steps. You're going to set your equation equal to 0. In this particular example, the equation is equal to 18b instead of 0, so I do need to subtract 18b from both sides. That's going to leave me with this equation going from highest exponent to lowest. The next step is to factor completely. So I have a GCF of 6b, so I'm going to factor that out. That's going to leave me with 2b squared plus 1b minus 3. I have a trinomial that will factor again into 2 binomials. Since my last term is negative, I'm going to use my sign rules, and my signs will be different. I'm going to use a 2b times a 1b. That's going to give me my 2b squared. And then I'm going to use a 3 and a 1. I could use a 1 and a 3, but the 3 needs to go with the 2b because my inside terms here are going to multiply to be 3b. And the 1 needs to go with the 1b because that's going to give me a negative 2b. And those two are going to combine to be 1b, and that's what my middle term is. On the last step, we're going to set each factor equal to 0. So we'll set 6b equal to 0. Solve for b and we get 0. We'll set 2b plus 3 equal to 0. We'll get 2b equals negative 3. Divide by 2, b equals negative 1.5. That's our second solution. And then our last factor, b minus 1 equals 0. Add 1 to both sides, and b equals 1. So we have 3 solutions, 0, negative 1.5, and 1. And I think this is my last example. If you have a quadratic, so that means your highest exponent is 2. So for example, if I make something up here, x squared minus 5x plus 6 equals 0, you do have to make sure that your equation is set equal to 0. Your a is always your coefficient of your x. So in this example, a is 1. Your b is always the coefficient, your a is always the coefficient of your x squared. So a is 1. Your b is always your coefficient of your x term, so that's negative 5. And then your c is always your constant. So we just plug into this formula, and it would look like this. X equals negative b plus or minus square root b squared minus 4 times your a times your c, all divided by 2 times your a. A negative times a negative 5 is going to give you a positive 5. Underneath here we end up with 25 minus 24, which is 1, and then 2 times 1 is 2. If the number under your radical is a perfect square, you'll go ahead and simplify that. Sometimes you have to leave the radical because the number is not a perfect square, and you'll just have to deal with it based on what situation you're in. And then this is going to be 5 plus 1, which is 6, and 6 divided by 2 is 3, so one solution is 3. And then I have to do the minus part of the problem. 5 minus 1 is 4. 4 divided by 2 is 2. So those are my two solutions, 3 and 2. Alright, that was my last example. Hopefully this video was helpful. And again, this is a review of all things from Unit 3.